So welcome to BGP video trainings. Now in this section we'll start with some of the basics of BGP, like basic concepts and terminology. So if you just try to look into the basic things what we are going to see, first we'll start with autonomous system number. What is autonomous system number? And then we'll see the differences between IGP and EGP protocols, some of the basic features of BGP, and then we'll see the loop prevention mechanism in the BGP, and then finally we'll wrap up this video by understanding when it is more appropriate to use BGP and when it is not really recommended to use BGP. So let's get started first with autonomous system number. Now from our basic CCIE studies we already learned what is autonomous system number. Autonomous system number is simple. It's a collection of networks under a single common administrative domain. So that's what we say. It's a collection of routers under a single administrative domain. Like take an example, I go to an organization where it has a specific locations and all are part of the same organization. Let's say it is AS number 100 and this organization is, let's say, ABC, and all the routers within that organization will be represented with one number, and we call that as autonomous system number. Okay, now the next thing is, like similar way we can have multiple autonomous system numbers, and if you want to communicate within the same autonomous system number or within the same organization, generally we use IGP protocols, like whatever the protocols we learned in our previous videos in the basic CCNA, CCNP videos. So we call RIP version 2, IGRP no more used, EIGRP, OSPF, ISS, these are all IGP protocols. So the main difference is IGP protocols operates within the same autonomous system number. So if you want to communicate within the same organization or same autonomous systems, then we use something called interior gateway protocols. We call them as IGP protocols. So all these protocols listed here, they are typically your IGP protocols. But let's say if you want to communicate between two or more different autonomous system members, then we use an exterior gateway routing protocol, and the only protocol which is running on the internet, which is allowing you to exchange the route between two or more different autonomous system members, is BGP protocol. So BGP is the only protocol which is running in the internet backbone and which is majorly responsible for maintaining the routes or exchanging the routes between the two or more different autonomous systems. And the service providers use BGP protocol, and by using BGP they control all the routing information. So BGP is the only protocol which is designed for a huge network, that is internet. So we'll see some of the points anyway, more into that, more in detail about the BGP features. Now in this section we have seen the autonomous system number. It's just a routers under a common administration. Now if you are communicating between two or more different autonomous system numbers, like we are trying to see exchange the routes between two or more different autonomous system numbers, we use a protocol called BGP. Okay, so next thing what we'll see is we'll get into IGP routing. Like when we talk about IGP routing, we have seen static, default and dynamic routings, and inside that dynamic routing we have seen RIP, EIGRP, OSPF, ISS, all these protocols. So all these protocols operate within the same autonomous system numbers, so we call them as IGP protocols. But if you want to communicate between two or more different autonomous system numbers, we use a BGP protocol. So first we'll start with some of the basic features of BGP. Like BGP is a standard protocol. You can run this protocol on any vendor device, and it is an exterior gateway routing protocol. Exterior in the sense it is going to exchange the routes between two or more different autonomous system numbers. So we call it as exterior gateway protocol, and it is specially designed for inter-AS domain routing. Inter-AS means communication between two or more different autonomous system numbers. Let's say this is AS 100, want to communicate with AS 200, like I got a previous diagram. Between these two AS we use BGP protocol, and is specially designed to scale a huge network like internet. It supports classless, and then it supports all your FLSM, VLSM, CADR, manual and auto summarizations. All these things are supported in the BGP, just like we have in all our IGP protocols. And it's similar to your internal protocol. Updates or incremental and trigger updates are supported, and we call BGP as a path vector protocol. Now what is meant by path vector? So path vector is a method of sending the routes along with a path information. Like take an example here. I got a diagram here. You can see the diagram here. Now let's take an example. This router is going to advertise this 10.1.1.0 network. So now this router is going to advertise this network into the next autonomous systems, which means it is going from one AS to another AS. So it is going to carry that 10.1.1. network, and at the same time it is going to carry the AS path information. So it is coming from which AS? So 65,400 AS. Now when it sends, it is going to pass on this information to this router, and when this router is going to pass on the information to next router or next autonomous systems, it is going to carry that network information just like your normal IGP protocol, but it is going to carry the autonomous system path information. So it's going to say that it's coming from 65,400, that is this AS, and then it is going to this, it is coming from this 2 AS. So it's crossing these two autonomous systems and reaching here. And finally, when this router is going to send it to the other router, it is going to pass on that information like it is originating from this AS, and then it has reached the next AS, and then finally it has reached, this is the last AS. So we call this as AS path information, and when it is going to carry any routing update, it's going to make sure that it is going to carry this autonomous system path information. Now this is very useful, especially when you are especially in a loop prevention mechanism. There is something called loop prevention mechanism, which I'll be discussing in our next video, next sections probably. I'll get into that more in detail. Okay, so we call it as the path vector protocol, where it is going to carry the path information from which autonomous system hops it is moving on. So that is that's the reason we call as path vector protocol. And then some more differences, some more features of BGP. It sends updates to manually neighbors using unicast. So this point I'll get into more clear when I get into BGP neighbors. Now this point will tell that like manually you have to configure the neighborship. Now what is manually? Let's take an example. We got two routers, and if I'm running OSPF protocol or any other protocol, let's say EHRP protocol, by default when you advertise this interface, it is going to send a hello message to the other side of the interface, and then it is going to reply to that hello message. Based on that hello messages, they automatically establish the neighborship. So they'll automatically become the neighbors, and they automatically build the neighbor table. That is something automatic neighborship. But in BGP we don't have that. In BGP we have to manually configure the neighbor, which means we need to say that router 2, you are my neighbor. Let's say this is router 1, router 2. On the router 1 you have to configure a neighbor command saying that you are my neighbor, and on the router 2 you have to configure a neighbor command saying that router 1 is the neighbor of router 2. And if both the sides neighbor commands matches, if everything is properly configured, then you'll find the neighborship comes up. That's what manual neighborship configurations. We got some initial labs majorly dedicated on this. So I'm not getting into practical things. Probably in our next couple of videos, in the third or fourth video, probably we'll directly jump to these labs, where I will also show you the configuration, how it goes, and some more detail on whatever we discussed. So next thing, it's a BGP's application level protocol. For reliability, it uses TCP protocol. It works on port number 179. And the metric, it uses a lot of attributes. So we got a wait attribute, local preference, and AS path, origin, next stop. We got a lot of attributes. BGP supports very rich amount of attributes which can affect the path manipulation process. Like in OSPF, it uses bandwidth, and the default formula it uses is 10 to the power of 8 divided by bandwidth. In case of EHRP, it is going to use bandwidth, delay, load, MTU, reliability. In case of RIP, it is going to use hop counts. But in BGP, the path selection process varies, and it's majorly on these attributes. So more on these attributes, we'll definitely get into this in our advanced BGP concepts. So as of now, I can simply say that it supports rich attributes which can really affect the path manipulations. And then finally, administrative distance is 20 if the route is coming from external BGP, Again, we'll see the differences of external BGP and internal BGP also. If the route is coming from external BGP or from a different autonomous system name, that will have the administrative distance of 20. If the route is coming from the same AS, that's what we call as internal BGP, we have the administrative distance of 200. So again, more in detail about IBGP and BGP I'll be definitely covering in detail in our next sections. So here I'm just getting into some basic information which is going to define the features of BGP. So like if you remember, just now I discussed loop prevention mechanism in BGP. Now there is a possibility like you are connecting to internet and you are connecting to your service provider from one side, and probably you're connecting to another service provider from the other side. So you may be advertising your route, let's say 10 network, and this route is advertised to a service provider, or it can be advertised to some other autonomous system members, and from there it reaches the internet cloud, and from there is a possibility of the same route coming back again. Now that will again create the loop. But in BGP there is a rule that whenever a router sees its own AS number, like if you remember, just now I discussed the path vector behavior. Like take an example, I got this network 180.10.0.0/16. Now this network is originating from AS 100. When it sends to the AS router, the second AS or the next AS, it is going to carry the network information like 180.000 or 10.000, whatever it is, and it is going to carry the autonomous system path information saying that it is coming from 100. And from there, when it reaches the other AS, now the same network 180.10.0.0/16, it is going to carry the AS path information that it is coming from 100 here, and then reaching 200, and then finally reaching to my AS. And when this AS, it is going to forward it to AS 500. It is going to forward that network information with 180.0.0/16, and it's going to say that it's coming from 100. So in general it will be reverse, and then it's reaching AS 200 here, and then coming to 300. So which means now this routers will understand, inside these routers in AS 500, they will understand that this network is coming from 100 and then going to 200 and then coming to 300, finally reaching to my autonomous system members. Now after this, from here, this is again advertised back to AS 100. Now when it is going to advertise this information, now when a router receives this information, it is already running AS 100, and whenever it sees its own AS number inside that update, it's not going to accept the route. So this is the default loop prevention mechanism in BGP protocol. Whenever a routers, like you can see 180.10. network is not accepted by AS 100 as a prefix as AS in its AS path, this is a loop detection in action, default loop prevention mechanism in the BGP. So BGP will never install any route when it sees its own AS number. So I'm running AS 100 and I'm getting a route called 10. network which also have AS 100. So it's something originating from my AS and coming back to my AS again. So because when you are connecting to internet, definitely you are connecting to multiple routes, and there is a possibility that the routes will be coming from multiple sites, or the same route is coming back again to my AS. So this is something loop prevention mechanism you need to understand, the default behavior of the BGP.